So, kinematics second part, the equation of motion. You guys already know it, the basics, that V equal to U plus AT, S equal to UT plus half AT square, V square is equal to U square plus 2AS. Now, here only the T, that is the time, is scalar, and the rest V, U and A and S are all vector quantity. Okay, so these are the equation of motion for a linear body. Okay, linear body in linear motion. While this type of equation is not valid for a non-linear motion. Okay, now all this equation, it's very important that all these equations are valid only if the acceleration is constant. Very important, acceleration must be constant to satisfy all this equation. Now, stopping distance. Suppose a body is moving with a velocity u. Okay, now at time t, it has given a brake, due to which it has moved a distance s, and then it stopped here. Okay, and become rest. So when the brake is applied and a retarded acceleration is given in the backward direction, a retarded acceleration is given in the backward direction, as because the brakes have applied and the tire will create a friction in a backward direction, so the retarded acceleration is a, which is a negative. Okay, so we will use a basic, again, the equation of v square is equal to u square plus 2as. Okay, now the final velocity is 0 since the body is at rest, so 0 equal to u square. U square is the velocity with which the body was moving initially, so u square. Okay, minus, since acceleration is negative, minus 2a and s. S is the stopping distance. Okay, so now 2as equal to u square, or s is equal to u square by 2a. Okay, u square by 2a. So you can see the stopping distance s is directly proportional to the square root of its initial velocity. S equal to u square. This is directly proportional to u square. So a sum we will take, that is came into a JEEMAINS exam. So this came into a JEEMAINS 2022. Very important question. It is based on the previous theory. Okay, so the question is that a car is moving with a speed of 150 km per hour, and after applying the brake it will move 27 meter before it stops. If the same car is moving with a speed of one third means 50, then the reported speed with which it will travel a distance, that is the stopping distance. It has asked us stopping distance. Okay, so we already knew s is directly proportional to u square. Okay, now here the speed u is given 150 km per hour. Okay, and the stopping distance is given s equal to 27 meter. So when the body is moving with a 150 km per hour speed, if it applies a brake suddenly, then the body is moving 27 meter, and then it becomes stops. Okay, so what we will do, and the question asked is that if the same car is moving with a speed of 1/3, so s equal to s is directly proportional to 1/3 square equal to 1 by 9. So when the body is moving with a 1/3 velocity, the stopping potential will become 1 by 9, as s equal to u is s is stopping potential is stopping distance is directly proportional to the initial velocity. Okay, so this 27 so stopping potential previously this was given 27, so now it will become 27 by 9. Okay, so 3 meter is the stopping distance, 3 meter. Okay, so this question has been asked at JEEMAINS 2022. Very conceptual question based directly on the fact that s is directly proportional to u square, and stopping potential is basically u square upon 2a. Okay, so the next topic is vertical motion. So suppose you are throwing a ball or any object into the sky with a velocity u at time equal to 0, t equal to 0. So the body will move upward against gravity. So here you can see the velocity will be v, which is moving upward, but it is against the gravity, so the velocity ultimately is decreasing. Okay, so the velocity will go on decreasing in this motion, and at this point the velocity v top, that is the topmost velocity, will become 0. Okay, and the time which is it is taken is equal to the time of ascent or descent, that is t. Okay, time is t, and again the body will move free fall with gravity. Suppose here the velocity is v and it is moving in downward direction, and gravity also acting in downward direction, so the velocity is continuously increasing. Okay, and again here the velocity will be u, and t, time of flight, tf equal to 2t. Okay, so here the time taken to move to v top is t, that is time of ascent, and again which is also equal to the time of descent. Okay, so the total time of flight tf equal to toa, that is total time of ascent plus total time of descent. Okay, tf, and you can see that the maximum height at which the velocity becomes 0 at the topmost position, suppose it is taken as h max, height max, h max is the distance at which from initial position, that is you moving with velocity u, and v top equal to 0, the total distance is h max. So we will calculate the time and h max. So we could see that we already knew the equation that v equal to u minus gt, as gravitation is acting upon it. Here on the special characteristic, so here v top is equal to 0 and initial velocity is u minus g t. So time of ascent equal to u upon g. So this is the time of ascent, or equal to time of descent. Okay, and the total time of flight equal to tf equal to 2 times of and the total time of flight equal to 2u by g. Okay, and you could see we have already found a time taken for ascent, time taken for descent, and the total time of flight. Now we will find the h max. For that equation we will use v square equal to u square minus 2g h max, because h max at h max v top equal to 0, so final velocity v equal to 0, and u square minus 2g h max. So h max equal to u square by 2g. Okay, so from vertical motion of a body we have found that the time of ascent, time of descent is equal to t equal to u by g, and total time of flight equal to 2u by g, and the height, maximum height, is equal to u square by 2g. So we will move to the next part. Now see drop. It is very important. It is also an important concept. So when the body is at this position, we will move. We will free flow with acceleration due to gravity. Okay, so u at this point is 0 since it is at rest, and we will drop it, and here the velocity will become v. Okay, and here we will get v dash. Okay, so here let us calculate that total and the height, maximum height of drop. We can calculate h max and the velocity we will calculate. Okay, so suppose we are using the formula v square is equal to u square minus 2g h. Okay, now here v is the final velocity and u is already 0, and minus 2g and h is the height of the drop. Okay, so we can calculate that. So v square is equal to 0 minus 2gh. We can calculate from here the velocity v equal to root over of two gh is the velocity. Okay, and we can also calculate the height. So suppose the height is h equal to ut plus half at square. Now u is already 0, so h equal to h max that is the height of the drop, equal to half into minus g t square. Okay, so this is the height of the drop. Now since height is always a positive, so we will take as half gt square is the height. Okay, and again we could also equate the time. So the time will be from here, from equation this one, from this equation we are getting that time equal to 2h by g, and it's a root. So from this drop equation we can able to find the velocity v dash equal to 2gh velocity of the ball, the maximum height h max is equal to half gt square, and the time for which the ball drops from upper position to lower position is t equal to root of 2h by g. Okay, now the question is that a ball of mass 0.5 kg is dropped from a height of 10 meter. The height at which the magnitude of velocity becomes equal to the magnitude of acceleration due to gravity is. Okay, so it's a very important question. It has came at US JEEMAINS 2022 26 January shift 1. Okay, so the magnitude of acceleration due to gravity becomes the magnitude of velocity. So the velocity will become 10 meter per second, since the magnitude is similar to that of acceleration due to gravity. Okay, 10 meter per second is the velocity. So let's begin the diagram. Okay, it is given 10 meter. Alright, so the next question is that a ball of mass 0.5 kg is dropped from a height of 10 meter. Okay, the height at which the magnitude of velocity becomes equal to the magnitude of acceleration due to gravity is dash meter. So it's a very important question, and it is also a tough question because you don't have the idea about the magnitude of acceleration and the magnitude of velocity. So the magnitude of acceleration is 10 meter per second square, but we have to take the magnitude. So the velocity will be 10 meter per second. Okay, we have to consider the magnitude. So g equal to v equal to 10 meter per second. This question has came into JEEMAINS 26 June 2022 shift 1. So let's begin the diagram. So suppose here ball is dropping. The height is given as 10 meter. Okay, now suppose at this height h the velocity becomes 10 meter per second. So we already knew from the earlier equation that v equal to root over of 2gh. Okay, so v will be 10 equal to root over of 2 into 10 into h. Suppose at this height from the initial position, the velocity becomes equal to the magnitude of acceleration due to gravity, that is 10 meter per second, not second square. Okay, so squaring both sides, we get 100 divided by 20 equal to h. So h equal to 5 meter. So at height equal to 5 meter, the velocity will be equal to the magnitude of acceleration due to gravity. So 5 meter is the answer. Very important question, very important question. Now the next part is the 2G projectile motion. So a ball is thrown in an upward direction at t equal to 0 with a velocity of u. It's move upward, gradually move upward in a direction, and then falls back due to the acceleration due to gravity. Okay, so we will split the velocity in x direction and in y direction. So in x direction it is u cos theta, and in y direction it is u sin theta. Okay, so we will do a little bit of table in which we will split the x axis and the y axis. Okay, now here in x axis you could see that x component is u cos theta, while in y direction uy equal to u sin theta. Now here in x direction the acceleration ax is always equal to 0, while in y axis ay the acceleration equal to minus g. Okay, so now we will try to find the ux. Suppose ux, no, so vx, sorry, vx equal to ux plus ax t. Now in x direction the acceleration is already 0, so you could see that v component of x is equal to u cos theta, Similarly in y direction, here in y direction vy equal to uy minus gt square. Since ay equal to minus g, so you could see that u sin theta minus g t square is the y component of velocity. Now here vx is a constant. Why it's constant? Since theta is always a constant, u is also constant, while here vy is a function of time. With increase in time the velocity will already is minus component, so vy will decrease with increase in time. So first when t equal to 0 the vy is maximum, and here what will here at this point vy will be 0, vy equal to 0 at this point. Okay, so we will move into the next slide. So vx component equal to u cos theta, okay, which I have proved you. Now vy equal to u sin theta minus gt square. Now v net is the velocity of resultant of the x axis and y axis, so equal to square root of Vx square plus Vy square, which you will get that V net equal to U square plus G square T square minus 2 UGT sin theta root. Okay, and tan alpha is the angle. So tan alpha is, you already know that Vy upon Vx equal to A sin theta minus GT square by U cos theta. Now in the next part we will try to find the T top, that is the time of ascent or time of descent. We will find the total time of flight Tf, the maximum height at which the projectile motion is covering h, and the range, that is the maximum distance the ball has traveled from t equal to 0 to t equal to tf. Okay, so from the earlier equation of the vertical motion that we have done, we guys know that t top, okay, t top equal to time of ascent, that is the time taken from here to here, is the t top. Okay, is equal to u by g. But here in the projectile motion, ux is 0, and the component that is giving the factor is uy. Okay, so uy, and we already know that y and x-axis is the x-axis. Okay, so in the y-axis, the component of the velocity is u sin theta. So u sin theta upon g. This is the time of ascent or the time of descent. So the total time of flight Tf equal to 2 times of uy upon g equal to 2u cos theta, sin theta upon g is the total time of flight. Now similarly, the maximum height h, the maximum height we also calculated at the vertical motion diagram, that h equal to u square upon 2g, So but here the ux component is 0, so uy square upon 2g. Now uy square equal to u square sin square theta, upon 2g. So this is the maximum height at which the projectile motion is reaching. The total time of flight is equal to Tf equal to 2 times of u sin theta upon g. Okay, now another one is a range. So suppose a range is a distance traveled. So we will use the third law of motion, that is Sx. We will do the Sx. So the range, now we will find the range. Range is the distance which the body travel from t equal to 0 to t equal to tf, that is the time of flight. So we will use the third law of motion again, Sx. What's happening? So now we will find the range. So range equal to, we will use the third law of motion, that is Sx is equal to ux t plus half at square. Okay, now why we have used here the x component? Because the range is in x direction, so we will use this Sx. Okay, now Sx turns into R range when the and we know that in the x-axis acceleration is 0, so this becomes 0. So range equal to ux upon tf. T times t becomes tf, that is the total time of flight. Okay, so we will go to the next slide. Okay, so here we know R equal to ux upon t, ux into t, tf. Okay, tf. Now we already knew that we have found that ux equal to u cos theta into tf. Now here in the earlier equation we have found that tf equal to 2u sin theta by g. So we will put here tf equal to 2u sin theta by g. Now here we already knew that 2 sin theta cos theta is equal to sin 2 theta. This is the basic trigonometric formula. So we will put here, we will get that u square sin 2 theta upon g is the range. Okay, and again the range is this, fourth part is the range. Time of flight equal to what we have found earlier, is that 2u sin theta upon g. Time of flight is 2u sin theta upon g, time of flight. And the maximum height we have calculated earlier is that u square sin square theta is equal to u square sin square theta upon 2g is the height of the projectile motion. So these three are the basic formulas of a projectile motion. So now the special cases, we will do some special case. So what is the maximum range? So we know that R equal to u square sin 2 theta upon g. Okay, so the maximum, so the sin theta, the range will depend on sin theta, since u square and g are constant. And what is the angle for which the maximum projectile will happen is that sin theta is in this range. Sin theta is in this range. So maximum range is when sin 2 theta equal to 1. So sin 2 theta equal to 1. So 2 theta is equal to 90 degree. So theta equal to 45 degree. So it is said that when the body is thrown at an angle 45 degree with the ground, the maximum R max is obtained, maximum range is obtained. And what about if the angle is somewhere less than or more than 45? Then the range will certainly be less than the maximum range. Okay, now here again a body is thrown a body is thrown in such a way that the first body is thrown at a angle of theta with the ground. Here we will make sure that the range is same. So here we will do 30, and this is 90 minus 30. So if you observe closely, this angle the theta and 90 minus theta are complement to each other. So the height will be h1 and h2 and t1 and t2 for both the projectile. So what we will say that h1 into h2 is directly proportional to the range square, and t1 into t2 is directly proportional to the range. So these are some of the special case of the projectile motion. Now next we will move on to a question that was asked at your JEEMAINS 24 January 2023 sheet 1. So what does it says? The question is that the maximum vertical height to which a man can throw a ball is 136 meter. The maximum horizontal distance up to which he can throw the same ball is okay. So horizontal distance, horizontal height. So suppose a ball is thrown and it again come to this position. So we have already done that the maximum height for which we have already done previously that h equal to u square by 2g is the horizontal maximum vertical height. H equal to u square upon 2g, which is given as 136 meter. Sine square sine 2 theta upon g. Okay, so we will get the maximum range is 45, so sine 2 theta is 90, so equal to 1. So u square upon g is the maximum horizontal distance h. U square equal u square by g is the maximum horizontal distance. So we will just do 136 into 2, that is 272 meter. Okay, so 272 is the answer, meter is the answer. So the next question. Now two objects are projected with the same velocity u, however at different angles a and b with the horizontal. If a and b is 90 degree, the ratio of horizontal range of the first object to the second object. So it's a very easy question. 25 January 2023 sheet 2. It is based on the formula itself. So we know that range r equal to u square sine 2 theta by g. Okay, now for the first at angle a r is equal to at angle a ra equal to u square sine 2 alpha a 2a by g. Again r p equal to u square sine 2b by g is the horizontal range for b angle. Now we have been given that a plus b equal to 90 degree. So b equal to 90 minus a. Now putting it in this equation, equation 1, So we get u square equal to sine 290 minus a by g. Okay, so ultimately we are getting u square sine 180 minus a by g. Okay, so ultimately we are getting, since sine 180 minus a is equal to sine a, so we are getting u square sine, here it is equal to 2a sine 2a by g. So if we do the ratio of RA by RB, we are getting u square sine 2 alpha by g by u square sine 2a by g. So we are cancelling it and getting the ratio of 1:1. So the ratio of oriented range of the first object to the second object will be 1:1. It's a very important question, as a really standard question. Now a stone is projected at an angle 30 degree to its horizontal. Okay, so we will dot the diagram. Please ignore my handwriting, it's very bad. Suppose a stone is projected at an angle 30 degree to its horizontal. Okay, the ratio of kinetic energy of the stone at the point of projection, so the initial position to the kinetic energy at the highest point of the flight will be. Okay, so the projection is like this, and here we will get that it's moving with a velocity u, and here at the topmost position it is moving in this direction, so u cos 30 degree, since it is making an angle 30 degree with the horizontal, u cos 30 degree, so equal to root 3 by 2 u. Okay, so again, so the kinetic energy at point of projection equal to half m u square, since the initial velocity u square, and the kinetic energy at the maximum at the topmost position, kinetic energy at the topmost position is half m is the mass of the body, and root 3 by 2 u square. Okay, so finally we are getting half m into 3 by 4 u square, 3 m u square upon 8. Okay, so we are getting we will have to calculate the ratio. So ratio is half m u square upon 3 by 8 m u square. M u square is cancelled, and 8 and 2 is cancelled, or 4, so it will be 4 upon 3 is the ratio of kinetic energy of the stone at the projection to the kinetic energy at the highest point of the light. So the ratio is 4:3, and this has came into your JEEMAINS 29 January 2023 shift 1. So this is the last part of the kinematics. It's a horizontal projection. Now suppose a body is moving, is thrown from a height h above the ground, and it is thrown with the velocity of u at time equal to 0. So it will move under the influence of gravity, and it will strike the ground at suppose time equal to t, and the range is denoted as r. So we already knew that from the free drop of the ball we have studied that time t equal to root over of 2h by g. Okay, and the range here, see here two component of u is taken, ux and uy. Since it is moving under the influence of gravity, so ux equal to u and uy equal to 0, since there is no y component here. So ux is the only driving force, driving velocity. Now suppose if you want to find the range equal to ux into t. We already knew that ux equal to u and t equal to root over of 2h upon g. So these two are the very important equation. So these two are the very important formula, that is the time of flight, that is t equal to root over of 2h by g, and the range of the horizontal path is equal to r equal to ux into t, that is u equal to u equal to root over of 2h by g. So in this way kinetics is finished. We will next move to laws of motion. Thank you.